Welcome everybody to the Cloud Online Meetup. Today's topic is going to be deployment models for OpenStack with Platform9. We will have two presenters from Platform9 today, Sirish and Rahul, and they will discuss existing design patterns for deploying OpenStacks. And after reviewing current patterns and their strengths and weaknesses, they will introduce Platform9 Management OpenStack innovative new model, which is OpenStack as a service. And we're happy that you joined us today for a discussion on the rationale behind this disruptive new model and how it could offer the simplest operational experience and lowest total cost of ownership for cloud infrastructure in the years ahead. A few logistics before we get started. This session is going to be recorded and it will be available within the next 48 hours so that you can review it, share with colleagues, etc. And the slides will be obviously available as well. If you have any questions during this session, feel free to ask those by using the chat on the left-hand side of your web panel. And with that, let me hand over to Rahul. Rahul, the stage is yours.
Thank you, Rafael, and thank you everyone for showing up. Good morning. It's Tuesday morning here in California, and I hope you guys are having a great start to the week. My co-founder, Madhura Maskowski, and I are here to talk about the deployment models for OpenStack and the work that we're doing at Platform9 to make a brand new model available for the world at large, giving you choice versus the options that you already have. So let's get started. Just a quick recap into what we're going to be doing is, starting with OpenStack, I'm sure the audience here is very knowledgeable about OpenStack, so we can go as deep or as quickly as you'd like. Feel free to ask questions at any time. And then we'll review some of the deployment models that are popular, and then talk about Platform9's approach. And I'd like Madhura to lead a demo of Platform9's approach in action, and we can then top it off with some Q&A. We're here to answer any questions either during the call or even afterwards if you'd like. Quickly introducing my co-founder, Madhura Maskowski is here. Madhura, do you want to say hi?
Hello. My name is Madhura Maskowski, and I'm the...
I should say she doesn't always sound like that. This is very, very early in the morning for her. But
that's right. I'm the co-founder and VP of product at Platform9. And before starting Platform9, I spent about 7 years at VMware as a staff engineer, where I was the technical lead for various products as part of VMware's management portfolio, including vCloud Director and vCenter, etc. And prior to that, I spent about 1.5 years at Oracle as part of the database team. And before that, I pursued masters at Stanford.
And folks, I'm Sirish Raghuram. I'm the co-founder and CEO at Platform9. I was at VMware for nearly 12 years before I first started there when Windows XP wouldn't boot because of changes to the SCSI stack, and that was my first work there. And I left with Madhura and 2 other co-founders to start Platform9 in late 2013. At VMware, I had technical and management responsibility for several VMware products, especially in the vSphere business unit. So let's talk about OpenStack. Obviously, it's very popular, but did you know that it's the world's top platform for private clouds? And what I have here is a Google Trends comparison of OpenStack search interest in comparison to VMware vCloud's search interest, which happens to be the world's top, it used to be the preeminent one before OpenStack came about. And you see today that there is just a lot more interest in OpenStack, and for good reason. It's also the second biggest open source project of all time, behind only Linux. So it's obviously very exciting, very popular. There's a lot of interest. And it has a great architecture. So the focus of this talk is not necessarily OpenStack architecture, but in case there's folks on the call who aren't as familiar, I'd say that OpenStack has a very services-oriented architecture, loosely coupled services exposing REST APIs, communicating over message queues. So it's got good bones. And a lot of these services were inspired by Amazon Web Services, so it's based on a good, sound design pattern. Keystone is the identity service, Nova the compute and aggregation service, Glance is the image service, Neutron enables integration with external network control planes, Cinder enables integration with block storage, a wide variety of block storage solutions that a customer may deploy. So it's got great loosely coupled architecture for a cloud platform. And that architecture is fundamentally decoupled from whether you're using Linux with KVM underneath, or VMware with vSphere underneath, or in the future maybe Docker with Docker containers running on bare metal. And the consumption of this cloud platform is made possible through a user interface. OpenStack's most well-known user interface is Horizon. At Platform9, we have our own user interface called Clarity. There's the CLIs and tools, including Ansible, Salt, Puppet, Chef, the scripts that you can write against the APIs, and there's Heat, which enables you to orchestrate application stacks or the underlying cloud platform. So it's got a great service-oriented architecture. It's very popular, as we spoke about. But OpenStack true cost of ownership, or total cost of ownership, if you talk to customers who've deployed OpenStack at any scale, they do talk about how challenging it is. And this is a quote from an analyst. It's one analyst's viewpoint. I'm sure there's variations around this. But the point that the analyst was making is VMware doesn't need to worry about OpenStack. This is a while back. VMware doesn't need to worry about OpenStack because when you take a 25-rack infrastructure, while OpenStack has a very low perceived cost, when you take into account the true total cost of running OpenStack at scale in production while supporting workloads and users depending on that infrastructure, the analyst estimated that the operational cost is high. You need nearly 20 engineers to support a 25-rack infrastructure. Now, you could debate this, right, and the numbers, I think, do vary. But the point is that this is an opportunity for us in the OpenStack community to make it more efficient and make it better for customers. And that is the opportunity for us and others in the community to innovate around. The other thing I want to point out is that upgrades are tricky. This data comes from the most recent Foundation survey, which came out in November of 2014. It's available at the OpenStack Super User website. Now, what it shows is that 78% of the surveyed respondents were on a version that's at least 2 releases old. And if you look at, I think Havana was actually a fairly mature release. So, and this survey happened right when Juno came out. So it's probably okay to say the people on Havana are probably okay on it for a while. But if you look at Essex and Folsom and Grizzly, and if you compare it to OpenStack today, Juno is so much better than those versions. And for someone to hold on to those versions, the only explanation is that upgrades are really hard. There's no rationale for someone holding on to that older version of OpenStack when the framework has enhanced so much. So that is a challenge where, again, I think customers should have an easier way to get the latest and greatest technology advancements that are happening in the framework. And analysts also talk about, they reflect this, which is basically something that comes from customers, which is that for the enterprise, which is used to a very packaged, supported, consistent, and easy-to-use product from VMware, they struggle with adopting OpenStack because it's hard, it requires a different set of skills, and it's very time-consuming for them to adopt. And that is, again, an opportunity for us to make OpenStack easier. So I want to set that context and talk about how OpenStack has a great architecture, great bones. It's extremely popular. Obviously, the world's most, it has a top interest in terms of people who are looking to run a private cloud platform. But there are some challenges which, is up to us in the community to solve. And a lot of this comes down to, mismatched expectations. OpenStack is a modern distributed systems-oriented, services-oriented framework. It isn't a push-button packaged easy product. There are vendors who are trying to make it so, but a lot of customers are sometimes surprised, not maybe upfront when they get the OpenStack up and running, but later when they actually use it and they realize all the costs that are involved and things that are needed to keep it running. Because it's a framework. You need to be thinking of it as a framework that you are committing to invest development resources on. So with that background, let's talk about OpenStack's deployment models. And the first model is probably the traditional one and the most popular one, is an on-premises distribution. The idea is that someone in IT installs, configures, monitors, troubleshoots the OpenStack deployments. The great thing about this is that it works with the infrastructure that you have. It could be a combination of infrastructure that you're running in-house in a data center versus in a co-located data center. it gives you flexibility, right? So you have complete control in terms of exactly tweaking OpenStack to run exactly what you want and not run what you want. But that, the downsides of that is that you as in the operations team now have the burden of installing, configuring, and troubleshooting and upgrading to new versions. And if you're successful, if you have the skills required to pull this off, it could be very cost efficient. But if you're surprised by the complexity of it, and if you go into it not planning for the time commitment that it may involve, it's not just a matter of skill, it's also the time availability for the skilled resources that you have, and do you really have the time for them to be spending time on keeping the OpenStack environments up and running. If you do, it could work out to be very cost efficient, but this is a model where people have a high degree of variation in terms of success. Again, from the survey from the OpenStack Foundation survey in November, the three most popular deployment tools, especially for production workloads, seem to be Puppet, Ansible, and then Chef. And what those tools let you do really well is the installation and configuration. We've studied all of those. We know that it's not just the initial installation. The installation and configuration works very well, but what about the monitoring, and what about the troubleshooting, and what about the upgrades? That's what you're committing to when you have a private cloud that's running for years. And those are the areas where these tools, which we spoke about before, Puppet, Chef, and Ansible, they don't really have great support for that. We speak from experience because we actually try to use some of these tools ourselves. And at Platform9, we upgrade quite frequently. And what we found was the upgrade path was kind of advisory, saying, Puppet help, the Puppet scripts, for example, would help you deploy a new OpenStack environment and maybe let you have a new environment that you could somehow port to, but it was pretty manual and there wasn't a lot of automation. So the point is that a lot of the costs and complexity come from the monitoring and troubleshooting and upgrades, not just the initial installation and configuration. And those tools just help you get an OpenStack environment up. What you really need to be thinking about is the long-term cost of keeping it running and moving to new versions and having a way to troubleshoot issues and resolve them quickly. The second model is a hosted private cloud. This is where an organization goes to an external service, a third-party service provider, and uses infrastructure that they are running, which they're making available as an OpenStack-based private cloud. The service provider in this model does the heavy lifting in terms of configuring OpenStack, deploying it, monitoring it, upgrading it, owning the SLA around the OpenStack private cloud, including the underlying infrastructure, but also the management system. So for a user, an organization that's consuming it, it is a lot simpler, right? You can sign up, and you have someone who's owning the SLA. There's a contractual nature to this relationship, and you can just use it, not have to worry about all the nitty-gritties that the service provider is coming in to do. Some of the downsides with this approach involve, the data lives outside your infrastructure. For some organizations, that's an issue. There is an issue where if you're an organization that has a lot of existing infra, then this model doesn't help you work with that. You end up creating a new silo which has new capacity, but if you have existing capacity that you want to use, you can't really do that with this model. And the costs, because the service provider has to invest the total cost of the human resources, the underlying infrastructure, and they themselves have to deal with the operational complexity of OpenStack, the costs are much higher than if you were to be able to deploy your own OpenStack management system. So, and some people we've spoken to look at this and say, why not just use the public cloud? I mean, the lines between this and an Amazon VPC are a little blurred, and why not just use the public cloud? And there are some reasons why this could be better, but it is an option for customers to consider as well. What's interesting to see is that the simplicity of this model seems to be driving far greater usage in production versus the on-premise model. Again, this data comes from the OpenStack Foundation survey in November, and I want you to notice two things. The top two formats are obviously the on-premise private cloud and the hosted private cloud, which is model number 1 at the top and model number 2 on the second. And if you compare the ratio of production workloads to test and dev or proof of concept like workloads, the relative ratio of hosted private clouds is much better. So what you can infer is that the simplicity and the fact that people are able to get up and running without getting bogged down or thrown off by the complexity of OpenStack is making hosted private clouds easier to run in production than an on-premise private cloud. And it makes sense, right? Because if you're not able to get it up and running, how would you trust your critical workloads to it? So what I want to draw your attention to is the ability to spin up an OpenStack environment with confidence and have an SLA around it that you're not responsible for is encouraging a larger pool of customers to trust this model. And I think that's something that we should be inspired with, because it's something that we should strive to achieve. So when we started Platform9, the question we asked ourselves was, is there a way that with which we can get the best of both worlds? Can we get the economics, the data locality, and the flexibility of infrastructure choices of the on-premise approach, and combine that with the convenience and operational efficiency of a hosted private cloud? And clearly, if you could achieve both of these, then you're kind of giving the best of both worlds to the customer. And that's the question we asked ourselves. So with that, let me introduce Platform9's model. And we expect that this is a model that will become more popular over time. We are the only company right now to have this, but we would love for more of the community to pick up this model and make it more mainstream. And this model is OpenStack as a service. We've released Platform9 Managed OpenStack recently, which is an embodiment of this model. But conceptually, the idea is that your service hosts your data. Platform9 hosts the OpenStack controller as a service with an SLA. So the idea is that an administrator in your organization can just sign up, and they get an OpenStack environment, an OpenStack management fabric that is completely set up, configured for them, and all they need to do is mix in the resources, the underlying servers and networks and storage. And Platform9, or some other, in the future, other companies could be taking the complete responsibility for managing that OpenStack management fabric. And this includes not just the initial installation and configuration, but monitoring it, troubleshooting it, upgrading it in case there are any issues, seamlessly without the end users, including the operational admin teams within organizations, having to deal with the complexity of it. So note that the workloads and data in this model, compared to the hosted private cloud model, the workloads and data stay entirely on-premise. And it works with any infrastructure that you have. So it could be a combination of on-premise infrastructure, co-located infrastructure. The model is agnostic, right? The idea is that you consume OpenStack as a SaaS service. You sign up and you use it with the resources that you want to use. So an illustration of this in action, just to reiterate the point, is you have a typical organization with infrastructure and operations team and end users, and you sign up. Someone in the operations team signs up for Platform9, and they get this entirely configured and ready OpenStack environment that's good to go. They download an agent and drop it onto the service that they have, at which point the agent starts reporting back metadata to the SaaS-based OpenStack environment, helping it detect the metrics that it needs to construct a cloud topology. And OpenStack's management systems then take over, logically transforming the disparate pool of underlying resources into one large cloud, one large pool of resources, which IT then makes available via self-service to the end users in the organization. Could be to junior admins, could be to developers, could be to test audiences, could be to lab-oriented audiences. So IT gets a lot of help, right? They are able to do what is their core, they are able to go about achieving their core mission with a lot of help from Platform9 or a SaaS-based OpenStack vendor, because they don't have to deal with the complexity of the management system. They just focus on using it and the policies in their infrastructure. They continue to have full control over what infrastructure is being used and which users have access to what resources. And end users, in turn, they get a fully self-service, agile cloud environment without any of the complexity and having to wait because the environment isn't ready. So that, in a nutshell, is Platform9's model, OpenStack as a service. And with that, I'd like to bring in Mathura. And Mathura, would you like to walk the audience through a demo?
Absolutely. Thanks, Shirish. Hi, folks. I'm Madhura Maskowski, and I'm the co-founder and VP of Product at Platform9. I'm going to structure this session into two parts. In the beginning, we're going to look at a recorded demo, which is going to show to you just how simple and easy Platform9 makes it to get started with your OpenStack as a service private cloud. Right? So I want to highlight some of our key differentiators in terms of simplicity of deployment model and benefits of it to you as an end user. And then we're going to switch into a live environment. And I'm going to use that environment to give you a much more in-depth perspective into some of our advanced features, such as resource sharing and policy-based placement automation, etc. So let's get started.
You want to switch to the live environment, please? Here's the live environment.
So folks, what we have in front of us is a Platform9 live environment. And I have about 5 physical servers that are paired with this Platform9 cloud. And signed in as an administrator user, and this is one of our internal environments. So the model that works for you as an end user is that when we deploy a Platform9 account for you, then you get a dedicated URL, something like your company name.platform9.net. And behind the scenes, we deploy a logical instance of Platform9 managed OpenStack, and we create an isolated deployment primarily on your behalf, right? So it's not shared with any of Platform9's customers. And then associated with that Platform9 OpenStack deployment, what you get is a couple of software agents, right? And these are RPMs or Debian packages in case of Linux infrastructure, and this would be a gateway or an appliance in case of a VMware vSphere environment. And so let's look at the process to pair your existing physical servers with your Platform9 cloud. Right, so the model is really simple. When you sign into your Platform9 account, the first steps that you would do is to add your physical servers to the cloud to get started. So let's look at the process to do that here. The process is really simple. It's a 3-step process. The first step is to download and deploy a physical agent. Now, this demo is demonstrating Platform9 managed OpenStack with Linux KVM infrastructure. And so we support all popular Linux distributions, Red Hat, CentOS, Ubuntu. And so as a first step, we're going to download a Linux RPM. This is a software agent for Red Hat or CentOS systems. It's a really lightweight agent. It's about 3 megabytes in size. And then as a next step, we're going to copy over that agent to one or more of our physical servers.
And let's show that with the recorded environment just for convenience. So here's the YouTube recording. It's also available. I want to reference the YouTube recording because I think it's the wrong video that's playing. Let me just go back to this. Here we go. So Mother, if you want to just walk them through, make it full screen, and then walk them through this portion, and then we can flip back to the live environment.
Yes. So when you sign in for the first time into your brand new Platform9 account, a dashboard presents to you a wizard that guides you through a step-by-step process to do the portion of pairing your physical infrastructure with Platform9. Right? So the first step of this process is to authorize one or more of your physical servers to be part of your Platform9 cloud. The process is really simple. We already looked at downloading the RPM as a first step. So I'm going to move forward a little bit. And so we downloaded this agent RPM. And what now we're going to do is we're going to copy this RPM into a CentOS physical server. Our internal data center runs primarily with CentOS operating system. So I have a CentOS server running in our lab environment. And I'm going to copy over this RPM now onto that physical server. So we're copying that RPM 10.4.53.82. And so all we need to do from your perspective is to copy over the RPM on each and every physical server that you have within your data center. And I want to highlight a key point here. With Platform 9, this is the only piece of software that you will ever have to install, right? This is the only component that you ever deploy and download, because once the agent gets deployed on your physical servers, it then does an initial discovery and it acts as a bootstrap agent, which then installs any required OpenStack dependencies or Nova drivers or etc. on that physical server. And on an ongoing basis, the agent is then responsible for deploying any required software packages on that physical server. So we just finished the deployment of the agent. The agent has been successfully deployed. And now, as we switch back to the infrastructure view, back to our Platform 9 account, we will see an updated alert telling us that one or more of our physical servers are awaiting authorization. So for this demo, I had downloaded and deployed the RPM on about 7 physical servers or so within our lab environment. And so we see all of those servers awaiting our authorization now in the Platform 9 dashboard. And so the next step, we're going to authorize and make all of these servers part of our cloud. Right? And this is a two-step process on purpose to ensure that you're absolutely making the right servers that you want to be part of your cloud. You're authorizing them to be part of your cloud, right? But some accidental installation of an RPM, etc., doesn't automatically make that server to be part of your Platform 9 cloud. So we just authorized one server to be part of our cloud. And now that server is awaiting in discovery mode. And what happens during discovery is that Platform 9 then looks at what is available on that physical server, and it tries to pull in additional dependencies and get them installed on the server. And so there's one key point that I want to highlight here, which is that during authorization of your physical servers, we're also assigning roles to these servers. And this is one key differentiator with Platform 9's OpenStack as a service deployment model, because by this simple mechanism of assigning roles, we are behind the scenes configuring your OpenStack private cloud on your behalf. Right, so for this particular physical server, I assigned it an image library role, and I'm going to go ahead and authorize the server now. And what that means is that Platform 9 is then going to take the storage backend associated with that server, and it could be local storage or it could be an NFS shared storage. We work seamlessly with both, and it's going to convert that into a glance-based image catalog. And so if you look at this, the role field here, we notice that the first server was given a hypervisor role, while the second server was given a hypervisor and image library role. And so that indicates that the server is also enabled to be the backing for your glance image catalog. So this is how simple your initial setup of deployment process is with Platform 9. You pair your physical servers and make them part of your Platform 9 cloud simply by deploying the software agent that should be that is dedicated to your Platform 9 account on each of those servers. And so now that we've looked into the initial deployment process, I'm going to switch into a live environment, and we're going to use that environment to get a much more in-depth perspective into various features that Platform 9 supports. Right, so in this environment, we have about 5 physical servers, and I had deployed the software Platform 9 agent on these servers. These are Linux servers and POS machines. Zooming into each server gives us details about everything that's configured on that server, what virtual machines are running on it. Looks like this server doesn't have any VMs running, what networks are associated with the server. Going back to the infrastructure dashboard view, this view is designed to give you as an administrator a perspective into all the capacity that you have within your Platform 9 cloud, right, across compute, memory, storage, and network. Now, when you pair your servers to be part of your Platform 9 cloud, we automatically discover any storage as well as networks associated with those physical servers. So the storage could be local storage or NFS shared storage. We work seamlessly with both. And for networking, we make a simplifying assumption that across your physical servers, you have defined one or more Linux bridges And across different servers, you have named the bridges with the same name as long as they're associated with the same underlying physical network. So with that simple assumption, we are able to show you this topology of your physical network the moment you pair your physical servers to Platform9. So this data starts becoming available to you right away as soon as you pair your physical servers. And then you can do things like you can make a pool of physical IP addresses available to one of your networks so that Platform9 can use that static IP pool and customize virtual machines and assign IP addresses from that pool. Or you can say that my network is DHCP configured and it's backed by a DHCP server. So in summary, once you pair your infrastructure, your storage and networking kind of automatically gets configured. Your image catalog gets set up automatically, and it's available for you to start capturing golden template images, etc. And there is one more key thing that Platform9 does as part of this setup process, which is a big differentiator in our model, which is that we work seamlessly with both brownfield as well as greenfield environments. So all you need to give to us is a bunch of Linux servers that you've racked and stacked and configured with Linux bridges. And then we will pull in any Linux virtualization dependencies, libvirt, KVM, etc., and get those servers prepared to be part of your OpenStack cloud. However, if you do have existing Linux servers that have workloads running on them already, then we work with that just as seamlessly. So the Platform9 agent will then discover those workloads and they will start showing up to be part of your Platform9 cloud. And then at that point, you can organize those workloads in various ways. So you can select some of those servers and you can make them part of a different tenant, etc., by changing the ownership of those servers, just so that you can overlay some multi-tenancy on top of your existing workloads. So having said that, let's take a look at the process to set up your image catalog. We previously assigned the image library role to one of our physical servers. And with that, populating your image catalog is now as simple as copying your image binaries to this particular folder on the physical server that was designated to be the image catalog. So in this environment was 10.4.0.13. So as soon as you copy those images to that folder, they become part of your catalog and they appear in this image catalog view. Or you can do a URL upload of an image or a direct upload of an image as well. So as an administrator, after pulling together your physical resources with Platform9, you will then populate the image catalog. And once you're done that, you would likely want to define one or more of resource tiers within your infrastructure. And I'm going to show to you just how simple and easy Platform9 makes it to do that, right, by this mechanism of virtual clusters through host aggregates. And so defining a new virtual cluster, a new resource tier with Platform9 is really simple. Let's say that we have a QA team within our organization, which needs to be given its own separate tier of resources, which should not be shared with any other team within our company. So for that purpose, we will create a QA host aggregate. We will associate a key value pair tag. Let's call it QA tier is equal to true. And then we'll select one or more physical servers that we want to give access to our QA team. And so as we define this host aggregate, it becomes part of our Platform9 cloud. And let's see. So the host aggregate definition, I'm having a little bit of trouble here, but there are a couple of sample host aggregates that we've created already. And so these aggregates are a way to pull together your existing physical servers, right? So we had predefined a couple of QA host aggregate tiers with the key value pair tag QA server is equal to true. And so a number of things start happening when you define a new host aggregate with Platform9, right? First of all, we give you immediate visibility into your current capacity across compute memory and storage in the context of that tier. right? So this is a really simple way to look at how much capacity do I have in my Palo Alto data center, or how much capacity do I have in my Washington, D.C. data center across usage and allocation. Right, but this is not the only benefit of resource tiers. Once you define various tiers within your organization, now you can intelligently start consuming them as part of your multi-tenancy. So when you define multiple tenants within your organization, you can assign these tiers to be consumed by the tenant. So you can say that my production team should only use resources in my tier 1 virtual cluster or host aggregate, or the Palo Alto team should only consume resources from my Palo Alto tier, and so on and so forth. And so this is a key benefit for you as an administrator, because by isolating your physical infrastructure and creating different pools, you now feel comfortable giving self-service access to your end users, and you can ensure that they will only deploy their workloads on the appropriate set of resources. Right, and finally, once you've set up your Platform9 cloud, now from your end user's perspective, they will get a self-service portal access to Platform9, and they will get access as a self-service user to the image catalog, the instances, and the flavors that you've made part of the specific tenant that they're going to be part of. Right, so we are part of a service tenant now, which is default tenant that Platform9 creates when we deploy an account for you. But through multi-tenancy, you can define one or more tenants. And then creating new virtual machine is a simple process of selecting an image that you want to create a virtual machine from, applying a flavor to the virtual machine, selecting a network that you want the virtual machine to be deployed to, and note that all these resources were pre-allocated to the tenant that we are part of. Giving the virtual machine a name, specifying SSH keys that should be injected in the VM. And at this point, we're going to customize the virtual machine. We're going to give it an identity. We're going to say that you should inject the script to be your part of this virtual machine, or give it a default password. Or there are a number of things that you can do as part of the Cloud Init-based powerful customization mechanism. And so this is the process to get a new virtual machine deployed with Platform9. If you folks would like to learn more about how we support multi-tenancy, or how the virtual machine deployment model works, or how our REST APIs work, etc., feel free to reach out to us at info@platform9.com, or you can directly message me at madhura@platform9.com.
Thank you, Madhura. I hope you enjoyed the demo, folks. And we're going to switch back for a quick recap on the slides. And if you have any questions, excuse me, please feel free to ask. So I only want to recap a few points. Madhura already touched upon this in the demo. Platform9's control plane, which is what is made available as a SaaS service, this is the OpenStack controller, only receives metadata. It does not receive any data. So when Madhura deployed the VM, the image stays on your servers within your network. A new VM gets created on another server of yours within your network. All that happens outside is that the scheduler in Nova makes a decision about where the image is and where it's going to be deployed, and the actual data mobility happens entirely within your network. So it's metadata only. It's received via outbound HTTPS. The control plane is dedicated for customers, so there's no two customers that share a control plane. The control plane can be restricted to only be accessible from within your network. So this is where you really see the best of everything, where you have a control plane that's only accessible from your network, but at the same time, as a customer, you don't deal with any of the complexity of maintaining that control plane over time. We have multi-factor authentication for enhanced security. So it's a great combination of features, of security and convenience features that our customers definitely appreciate. So to recap, we are bringing a new model to the market, OpenStack as a service. We hope that the community likes this model, as our early customers do, and it becomes more mainstream over time. In fact, you increasingly see cloud-based management of infrastructures ranging from CoreOS and SwiftStack to Platform9's. And before all this, there was a company called Meraki, which pioneered this model with wireless access points. The promise of this model is it gives you the best of the two prior deployment models for OpenStack. The economics, data locality, and flexibility of choice of infrastructure that the traditional distribution model offered, along with the convenience and simplicity of hosted private clouds, which, as you can see from the most recent survey, is driving much greater production use of OpenStack. So this model offers the best of both of those options. And we think that in terms of relative choices, for someone for whom absolute time efficiency is the most critical need, a hosted private cloud is probably easier because you don't even deal with any of your hardware, right? You just sign up and you swipe a credit card and you get essentially a private cloud. It is more expensive, so it's not particularly cost efficient, but it is very time efficient. An on-premise OpenStack model we think has a high variation. It can be quite cost efficient, but this is where a lot of it comes down to the skills on your team and within your organization and whether you're able to get it running and keep it running. More important than getting it running, keeping it running at low cost without disruption, that's the hard part. And we think there's a high variation, but we think that it is also a compelling option for some customers. And where we see Platform9 or OpenStack as a service as a model is, it is a great combination of time efficiency and cost efficiency. So in summary, we're making private clouds easy for organizations at any scale. Please feel free to sign up for Platform9's free trial. You can reach us, follow us on Twitter. If you like what you saw today, we'd appreciate a tweet at Platform9sys. You can reach us at support@platform9.com. Our email addresses are also on our website. And we're here to answer any questions. While you answer questions, I would greatly appreciate it if you could take a brief 2-question survey. We want to bring a lot more great content to you with these webinars, and we want to hear from you in terms of the kind of content that might be most relevant to you. So here's the survey link. Just copy and paste it into a browser, bit.ly/platform9survey. And we'd really appreciate it if you can take the survey. And if you have any questions, please feel free to ask. I know there's some questions coming in on the chat panel, and we'll take them in order.
Rahul, thank you very much. There is a couple of questions from the audience, and while we're answering the questions that came in already, feel free to ask further questions if you have any. So the first one is this communication between Platform9 controller and compute nodes encrypted?
Yeah, Juan, great question. Thank you for asking. The answer is yes. So let me go back to that slide where you see this. And this is the SSL layer. If you can see my mouse, it's the compute node is on that server, the server boxes, and the deployment unit is where Platform9's controller essentially runs. And the way it works is that communication happens encrypted over SSL, and every deployment unit has its own dedicated root certificate authority. The agent that you download from your deployment unit is hardwired to only work with that root certificate authority. So there's mutual authentication that the deployment unit does on the agent that you download, and the agent does on the deployment unit that it is communicating with, and all of that is encrypted over SSL.
Thank you very much. The next question is, will the added hosts be used as compute nodes or as network storage nodes? Are there any prerequisites for the networking part?
Yes. So Sri Krishna, I think there's a question from Sri Krishna. The added hosts are used as resources, so compute, storage, and network. And let me answer this by flipping into the live view. If you look into the infrastructure view, and this is not special to Platform9, this is, I think OpenStack in general have this capability, but what we have done is, again, OpenStack is a framework and you can tune it in different ways. What we've done with OpenStack is we've taken the capacity, if you look at the server that's highlighted over there, and if you look at it, we've discovered all of its compute capacity and memory capacity and storage capacity and the networks that are available from there. And that is what you see reflected at the top in the cards. The aggregate compute, memory, storage, and network is what is inventoried from the underlying hosts. So in short, we use all of the resources that are available via your hosts. It's not just compute. And in terms of the prerequisites, there's at support, I should point this out. So you can go to support.platform9.com and how to set up network bridges. There's an article for Ubuntu, there's an article for CentOS. you can see what is required. But essentially, the prerequisite is that you need to have network bridges configured on the network, on the host.
Okay. Are there any prerequisites for the network part? Are there needs to be a few networks created for OpenStack?
Yeah, so I think we answered that question. So the only prerequisite is that you have network bridges configured on the compute, so on the host that you're adding. I think the follow-up question is, can this be tried with VMs instead of physical servers? Yes, the answer is yes, you can. And in fact, we have had some people try it. Just remember that if you're trying to deploy VMs on those VMs, then you're going to run into nested virtualization issues. But as long as the underlying hardware supports nested page tables, that should just work. And we, in fact, have used that extensively in our internal deployment. Happy to talk about that in a separate blog post or a webinar later. But I think the follow-up questions from Srinivas, before I hand the ball back to you, Rafael, is, will the Clarity UI be the only management plane available? What happens if the communications to the Platform9's control plane? So the UI that we think, we built Clarity because, not because we like writing code, but because we wanted to deliver a truly integrated user experience. This is the UI that our customers love. The APIs are all available. Underneath this are all of OpenStack's APIs, and the CLIs are all available. And you can also use all of the tools and automation. So if you want to use Puppet or Chef or Ansible or Salt, or you want to use libraries such as libcloud or libsphere or PySphere, all of those just work because it's all OpenStack APIs underneath. The APIs are also documented. OpenStack itself has API documentation. In our experience, the documentation is wider than what actually works. So as we built our UI, we've actually documented all of the APIs that are actually working and we are using internally at docs.platform9.com. And you can go down and take a look at some of the examples out there.
Okay. Concerning the network part, can this be tied over the VMs instead of physical servers?
The answer is yes. The answer is yes, Rafael.
Okay, great. I'm not sure I understand the following question. Will the Clarity UI be the only management plane available? What happens if the communications of the Platform9's controls plane?
I think what the question is asking is, what happens if the network link goes down? Is probably that's the question. And so this is something we test all the time. The great thing, and this is again, I wouldn't take credit for it at Platform9. It's OpenStack's architecture, which lends itself to be adapted so easily as a service distribution, which is really the work of the community. But the way it works is that OpenStack services, the communications between the compute nodes, the agent software that runs on your servers versus the OpenStack controller works over message queues. And it turns out that message queues can be easily tuned to be resilient to network failures. So if you have intermittent network failures, then what happens is that messages get queued and get posted when the network comes back up. So you might see some operations taking longer because the network was not available, but everything just works through intermittent failures. Madhura, is that?
Yes, that's accurate. And just to add to that, we assume that network failure, if any, would be intermittent. On Platform9 side, as far as our controller goes, we take in great precautions to make it highly available, and we take backups of data, etc., to ensure that there are no downtimes because of our service going down. And then, coupling that with the assumption that the network failure, if any, would be intermittent, gives you an almost seamless experience with Platform9.
Okay, so here comes the next question. Is your agent the only piece of software I need to install on the premise machines? Do you impose requirements on the networking which links to the on-premise hosts out of outbound HTTPS to Platform9?
So the answer to the question is yes. The agent is the only software, the piece of software that needs to be installed on premise, because the agent is then capable of pulling any additional software components from the controller, depending on what you have already installed on that server and what role you're assigning to that server. Now, as far as the question goes about the network link, There is, again, nothing special that you need to configure. We have, the agent is prepared to make an outbound connection to the cloud-based controller, which is simpler to configure with respect to your firewalls or proxies, etc. And we are capable of communicating through network proxies, if any, if you have them within your infrastructure. So, so there is nothing special that you need to install or configure there.
Okay. Are there any plans to integrate networking products, such as, for example, Cisco, CRS-1000, Juniper, or Brocade?
I think that's a great question. So in the version that you're seeing, we are not demonstrating integration of Platform9 with external network installations. And the answer to that is absolutely yes, because we think that's very important. And we will share more as we have an update on that, but not just on the network side, but also on the storage side. In addition to discovering any storage that's mounted already on the host, we absolutely are working on better integration with existing storage environments and block storage devices or network systems that you might have out there.
What about storage redundancy? Do I need RAID-connected storage? Do you create software-defined storage using on-premise storage?
Another good question. I think the way it works right now is Platform9 detects any available storage on the host that you've added. This could be a network file system mount. It could be a direct attached storage. So you could very well have RAID if you want to. It could actually be storage from a high-end array that you've exposed through NFS. So it exposes a wide range of possibilities. Now, regarding software-defined storage, yes, we have plans. Nothing that we can demonstrate at this point, but we have plans by which this will continue to work with the existing storage that's in the way we demonstrated today, but it will also integrate better with out-of-band block storage systems that you may have, or also create a software-defined storage pool out of a collection of resources that you mounted to Platform9. So the answer is yes, it's coming.
Great. So the last question that we have for now, for multi-tenancy, there's a notion of owner. How granular can one be with access controls for multi-user environments or multi-host-centric deployments?
Yeah, so Ronald, hi, this is Suresh. The way it works is it's pretty similar to OpenStack. We have two major roles right now. There's more available via the APIs, but in the UI, there's two major roles, which is an administrator and a self-service user. Now, I think, RBAC is one thing where you can slice and dice it in hundreds of different ways. We are working on expanding this, but right now, there's two. We think we may take it to 4 in the not distant future. And the idea is that we found that our customers are quite happy with what they see right now. Madhur, do you want to chime into that as well?
Yeah, and just to add to that, when you define a new tenant, and when you add users to that tenant, you can assign a role to that user in the context of that tenant. So you can make a user either administrator within the tenant or a self-service user. And so an administrator will have higher level privileges within that tenant versus a self-service user will only have limited access. And kind of going back to what Suresh was saying, our model is to give you a set of predefined roles, which we think cover 99% of the use cases, again, to retain that simplicity of user experience.
All right. So thank you very much, Rahul and Suresh, for the great presentation. Thank you, everybody, for attending us live. There's one more question that just came in. What's the pricing model, per hypervisor or per VM machine?
Is that a check you want to write us, Gonzalo? No, it's on our website. So you can go to platform9.com. Under the product section, you can see the pricing. It's tied per physical CPU socket. So it's very predictable, and that's on the business tier. And the enterprise tier, we're not publicly announcing the pricing, but the model is still the same. It's still per CPU socket, and it's not per hypervisor. So hypervisor, if you're running 2-socket servers, it's relatively straightforward math. We're not doing per VM pricing. And before I wrap up, I want to thank Rafael and the audience here. Thank you all for coming and taking part in this conference and in this webinar and asking us some great questions. And Rafael, thank you so much for allowing Platform9 to come in and talk. we've been participants in your webinars before and meetups before, and it's a great honor for us to have your support in terms of being able to come and share the work that we're doing at Platform9. So much appreciated.